Good day and welcome everyone to Power Bytes. I am your host, Lou Signorelli, and Power Bytes is your destination podcast for power generation conversations. As always, please know how much we appreciate you, our listeners. We hope you find the topics both helpful and interesting. There are several ways you can get in touch with the show. You can send us an email at powerbytes, that's power, B-Y-T-E-S, at cat.com. Visit us on Cat Electric Power on Facebook or LinkedIn. But please, if you've enjoyed your time with us today, please leave us a 5-star rating wherever you listen to your favorite podcasts. It really does help. So in a recent episode of Power Bytes, we featured application specialist Brian Snyder, and we talked about the different kinds of excitation systems and tried to really illustrate the basics of what they are and how to think through choices related to selecting the right excitation systems for your applications. Today, we're going to take things a bit further and we're going to look more analytically at the performance characteristics of permanent magnet, you may hear us refer to them as PM, and internally excited, or IE, type alternators. Caterpillar has recently published a white paper on the subject titled Cat Internally Excited IE Alternators. For a copy of this paper, simply go to cat.com and put excitation in the search bar. Joining us today via the Cat Electric Power Hotline from his home in Northern Ireland is the paper's author, Roger Rosborough. Roger has a master's and PhD in engineering from Queen's University in Belfast, Northern Ireland, and has 16 years experience in Caterpillar working in mechanical design, participated in the technology development of cooling systems, and most recently as a marketing industry consultant. Roger, thank you so much for joining us today.
Thank you for the invitation, Lou.
Roger, for those that did not hear our first in this series, let's start with some basics. Can you give us a brief recap on what is an excitation system and the different type of systems our customers will come across?
So in an alternator, the excitation system is the group of components which are used to magnetize the rotor. So most modern alternators are brushless, and they consist of a voltage regulator, an exciter, a rectifier, and some source of energy to power the exciter. So the excitation systems are typically categorized by the energy source. First type is called self-excited or shunt systems, and they receive power from the output of the alternator. The other two systems are separately excited systems because they're isolated from the alternator output. So another type that we've talked about is permanent magnet or PM systems, and they receive power from a permanent magnet generator. The final group is known as internally excited. That's because they use an auxiliary winding internal to the alternator stator, but isolated from the output connections. You can get more detail on all of these systems in the white papers written by Brian Snyder and myself.
Thanks for that recap, Roger. I really appreciate it. In your paper, you focused on a comparison of permanent magnet or PM style alternators and the internally excited. Why is a comparison of PM and IE even important?
PM excitation systems are often specified as a requirement from consulting engineers when requesting quotes. So this means that anything other than a PM would require an exception to be considered, and that's if it gets considered at all. An IE system provides a similar performance to PM when dealing with nonlinear loads and provides identical short circuit capability. Both of these systems are isolated from the output of the alternator and therefore should have equal consideration. The comparison is important as it should raise awareness of IE and its capability.
Good point. So why do you think consultants are tending to specify PM when IE seems to deliver relatively the same performance?
It seems that IE systems are not well known or not well understood. PM has been the traditional option of choice for some applications based on their performance. It is a separately sourced system and is not impacted by the disturbances on the output of the alternator. For this reason, it operates well with high nonlinear loads, like you might find in a data center, for example. They also have a high fault capability and high transient response capability, which makes them desirable for large systems or large motor applications. Another reason why PM is often specified is due to the presence of the permanent magnet generator, and this ensures that there's no concerns with the alternator losing its magnetism. In a self-excited system, the residual magnetism of the system is needed to begin the excitation process. If a self-excited system is not properly maintained or is not operated for an extended period of time, it's possible that the residual magnetism can degrade to a level that it gets to a point where the alternator is no longer able to operate. That's quite an uncommon scenario for most customers, but is a concern for critical applications. So while the PM is good for all of these reasons, the IE system is also a separately sourced system and also provides nearly identical performance to the PM. And in the Cat SR5 IE alternators, they also have permanent magnets embedded within the exciter field. And so any concerns regarding loss of magnetism are eliminated.
Very interesting, Roger. Can you tell me at a high level, looking at the two types, the permanent magnet PM or the IE, internally excited, what are really the key differences?
Well, that's a good question. Both the PM and the IE, they both provide such a similar level of performance, but yet there's a huge difference in how that is achieved. So the PM system uses a permanent magnet generator attached at the end of the alternator. Permanent magnet is attached to the same shaft as the alternator rotor and spins inside its own stator to generate an AC output to the voltage regulator. The IE system is different. It uses a series of auxiliary windings, which are in the main stator of the alternator. And as stated previously, these windings are isolated from the main stator, but are generating current from the passing of the rotor, just like the main stator windings. Both systems provide AC power to the voltage regulator separately, without impact from the output of the main stator or its connected loads.
So, as you were doing your research for your paper, Roger, what did you find were the key advantages of the Cat internally excited alternator?
So both the IE and the PM are so similar in their capability. It's quite difficult to differentiate between the two systems. The biggest difference, and thereby something that could be seen as an advantage of the IE, would be the footprint savings. So in the PM, as I've said previously, there's a large permanent magnet generator attached on the end of the rotor shaft, and this increases the overall length of the alternator, and that's not the case in the IE. Also, one other thing to note is that the IE system, there's less components than in a conventional PM, so you could argue that fewer components means statistically the IE would be more reliable.
More reliability is always a great thing in our business, right? Would you recommend the IE then in all applications, or is it best in one particular kind of scenario as another?
Well, in any application where a PM is considered, the IE should also be considered as an acceptable alternative. Both systems have separately sourced energy for the excitation system. That means they both provide exceptional performance for nearly all applications. However, there are certain applications where a self-excited system may be more appropriate than a PM or an IE. These may be where a customer is trying to have a low fault current. One example might be in a peak shaving application. So for that reason, the customer needs to understand their excitation systems and the performance differences they will achieve. It's also something to note about the IE systems. IE systems may not be offered with every alternator package. They are commonly offered with random wound and low voltage applications, but they're not restricted to those applications.
So Roger, I don't know if you could hear, but I've been feverishly taking notes as we've been talking. So let me see if I understand what your research revealed. First, the PM is certainly the industry standard and most often requested alternator type. Secondly, the internally excited alternator should be considered as an alternative for two real reasons, and these are what I have here. It has fewer parts and very similar performance to the PM, and as such should be intuitively considered as higher reliability. And Cat's internally excited alternator is smaller than the PM alternators and thus makes it a great choice when space and footprint are an issue. Did I get those right?
Yes, you did indeed, Lou. And yeah, I would recommend consult with your local dealer and discuss excitation options, and also consider the wording in your specifications so that options like the IE systems don't get ruled out from consideration.
Excellent points, Roger. Well, there you have it, folks. Thank you, Roger, for taking us through that today, and thanks to you, our listeners. If you would like a copy of the white paper we've been reviewing today, please go to cat.com and type excitation into the search bar. I did check that this morning, and a link to these two papers and many more is the first result in that search. If you'd like to reach us here at Power Bytes, please write us at powerbytes, BYTES, at cat.com, or visit Cat Electric Power on Facebook or LinkedIn. Till next time, thanks for listening to Power Bytes, and have a great day.